Okay, good morning. So yesterday we discussed internal resistance of a cell, and today we are going to discuss combination of cells. As you said, there are two types of combinations possible, that is series and parallel. What type of combination can you see here?
Series.
Series combination. Here for series combination, negative of one cell is connected to the positive of another cell. Again, negative of one cell is connected to the positive of another cell, like that. So here E represents the EMF of the cell. See, all of them are identical cells, so they have the same EMF. And R represents the internal resistance of the cell, and they have the same internal resistance. See, this is this a closed key or an open key, Irfan?
Close key.
Yeah,
Because
see,
the dot is there.
dot means it is a closed key, or the circuit is closed. So the current is flowing through this. So if the cells are connected in series, how can we find the total EMF? What will be the total EMF? And if they are connected in series, what will be the current derived from it? That is what we are going to learn today. So here, this shows the actual way when the cells are connected in series. See, positive is connected to negative. Again, next positive is connected to negative. This is how actually when we connect them in series. So let us see what will be the current drawn in this circuit when many cells are connected in series. So I would like to derive that equation. So look at the whiteboard while deriving that equation. Okay, can you see this? Can you see the whiteboard clearly?
Yes, teacher.
Okay. So I'm going to derive that equation here. Here you have already learned what happens if more resistance are connected in series. Suppose resistances are connected in series. This is a circuit. Small r, small r, small r. Three resistance are connected in series. What will be the equivalent resistance?
The sum of three of them.
Yeah, the sum of three of them, right? So R series will be equal to R plus R, which is equal to 3R. You have learned this before, right? Now, if cells are connected in series, the same law will be applied to it. Suppose this have EMF E, this have EMF E, this have EMF E, then the total EMF will be equal to E plus E plus E. What is that? 3E.
3E.
Okay, so if resistance are connected in series, you have already learned this way of adding them. Similarly, if cells are connected in series, you can add them up and the total EMF provided by the circuit will be 3 times the EMF due to one single circuit. Now, let us see what will be the current offered by that. So, let me rub this and
Teacher.
show one circuit showing
Teacher.
cells connected in series. I'll be showing here along with the cell its small internal resistance. Okay, I'm showing here only 3, but let us consider that it contains many, up to n cells. That's why I put dots here. This means there are more n cells are there. Suppose there are n cells and there is an external resistance capital R. So this is the circuit. You have identical cells having EMF E and internal resistance R. and there are n such cells connected. Is this clear to you, this circuit?
Yes, teacher.
So, due to this connection, the total current IS will be equal to ES divided by R plus small r. You learned small rs. You learned yesterday I is equal to E by R plus R, right? Now we have number of cells connected in series. So you have to use the effective EMF due to all those cells. And you have number of cells connected in series having an effective resistance Rs. Is this clear?
Teacher,
Yes.
the EMF value of every cell will be same in the
Yes.
same circuit.
Yes. Because I told the case when all the cells are identical. In this year, you are not learning what will be the case if each cell is different. For grade 12 level, you have to learn only what happens if all the cells have the same potential. Okay?
Okay, teacher.
So all the cells have the same EMF. So I will be substituting here N cells. So what will be ES? If N cells are connected in series,
NES.
NE will be equal to ES, where E is the EMF of one cell. Okay? So NE divided by R plus, what will be RS if there are N cells?
3R.
NR. NR. 3R if there are 3 cells. If there are N cells, NR. Okay?
But teacher, here is only 3R, right?
Yeah, I put here dots. Dots means there are
Okay,
more
okay.
such cells. I'm not showing in the figure. I cannot show N cells, right? It will go up to infinity. So I put here dots showing there are N cells.
Yes,
Okay? I have shown here 3. I can show here 2, 4 or many. But I cannot show N cells, right? N can be any number. So there are N cells. If you want, you can consider ES is equal to only 3 cells. So you will not get a general formula. That's why I'm using N here. Now, suppose what is R? The external resistance, right? This is the external resistance. If the external resistance R is very much bigger than the internal resistance of a cell, this will be the usual case. In most of the cases, the external resistance will be very much less than the internal resistance. So if capital R is very much less than small r, what will happen? We can neglect this small r. NR can be neglected. NR can be neglected. Okay?
So the value of NR will be 0?
The final NR is very small. Suppose R is, say, 100 ohms. Small r is 0.1 ohm. N is 10 cells. 10 into 0.1, 1. So this will be only 101. So we can round it to 100, right? So
Yes,
NR will be very small. I'm telling an example. Suppose R is 100. Small r is 0.1. Okay? Then R is very much bigger than small r. And if there are 3 cells, this 3R will be equal to what? 0.3. So R plus 3R will be what? 100.3. This 0.3 can be neglected compared to 100, right? That is why I'm telling, if capital R is very much bigger than small r, we can neglect NR and IS will be equal to NE divided by R. What is E by R? E by R is the current due to one cell. So this is equal to, this will be current due to N cells. N cells. Suppose one cell can provide 5 ampere current. it's an exaggeration. One cell can provide 5 ampere current. How much current will be obtained if we connect 3 cells?
15.
15. We will get 15 amperes. So if you connect more cells, we can get high current. If they are connected in series and capital R is very much bigger than small. Let us take the other case. This is case 1. Now case 2. If capital R is very much less than small r, this is very rare case. Usually the internal resistance of the cell will be very small compared to the external resistance. But there can be some cases, exceptionally less cases, where the external resistance is very small. What will be in that case? In that case, you can neglect R. R can be neglected compared to NR. R can be neglected. I'll give a case. Suppose R is equal to 0.1. Small r is equal to 100. Suppose. Then N into small r. If there are 3 cells, this will become 300. So 3 compared to 300.1, you can neglect, right? So in cases where capital R is very much less than small r, what will happen? Is will be equal to Ne divided by, I'm neglecting capital R. So you have Nr. So this is equal to E by R. So this is the current due to one cell. Okay. So suppose you have 3 cells. Each of the cell can provide 5 ampere current. But the external resistance is very less than the internal resistance. So what will be the effective current we gain?
5.
5 only. So is it useful?
So can you say again how 5?
Because suppose one cell can provide 5 ampere current. Okay. And the external resistance is very much less compared to internal resistance. So what will be the current obtained? Current obtained, even if you connect more cells, is equal to the current that can be due to one cell. Due to one cell. Okay. So if the external resistance is very low, even if we connect many cells, the resultant current will be only that due to one cell. So which is more profitable? If the external resistance is very large, which is more profitable? Connecting more cells or less cells?
Less.
Less cells, we will get only less current.
But teacher, in the second case also we are getting the same current, right?
No. First case, when external resistance is very large, the current will be n times if there are n cells. Okay. If the external resistance is very large, suppose one cell can provide 5 ampere. One cell can provide 5 ampere. Then if there are 3 cells, how many? It will be 15 ampere. If R is very much greater than small r. Okay. Now, if R is very much less than small r, in that case, if one cell can provide 5 ampere, then 3 cells also can provide only 5 ampere. So, is there any advantage in connecting many cells?
No.
No. So, series connection has advantage only if the external resistance is much higher than the internal resistance. Is that clear? When will we connect the cells in series?
Sure.
When will we connect the cells in series?
When in one switch all of the appliances will stop working.
Yeah, that's right. I'm asking in terms of the resistance. When will you connect more cells?
When the internal resistance is higher than the external.
Than the internal. When the external resistance is higher than the internal, we can connect more cells, then we will get high current. But if the external resistance is less than the internal, this is a rare case. There is no use of connecting many cells in series. We will get only the current due to one cell. Okay? Is
Teacher,
it clear to you?
teacher, I didn't understand this.
Which
Why
one?
the last topic now you said about this?
See, if the external resistance is very small compared to internal resistance, what happens? The current which we get from the circuit, even if you connect one cell, you will get 5 ampere. If you connect 10 cells, you will get 5 ampere. If you connect 20 cells, you will get 5 ampere. So is there any advantage?
No.
No. So why will you connect many cells? No need, right?
Okay, teacher, understood now. Yes.
So that is why I told only if the external resistance is very much higher than internal resistance, we need to connect the cell in series in order to get high current. Okay.
Yes,
So,
teacher.
so this is one case. Now let me consider the cells when they are connected in parallel. So our next topic will be, I will take a picture and keep so that later I can share it in your WhatsApp group. Okay. So let us consider now the another case which is called, okay, where to go for the share screen? Okay, it's here. So here we considered cells connected in series. Now, here I have told if the external resistance is much greater than the internal resistance, the current I will be n times that of any cell. So, we connect in series when we need large current. But if the external resistance is much less than the internal resistance, the current will be equal to that of one cell. There will be no special advantage. Is this point clear to you?
Yes, teacher.
So let
Yes.
us go to combination of cells. How are they connected here? What is this kind of
Parallel.
parallel?
Parallel.
So
Parallel.
we have already learned parallel connection of resistance, right? So you can already identify this. Are the cells identical?
Yes.
Yes, they are identical. They have the same EMF, same internal resistance. Now see, parallel arrangement means all the positive terminals are connected together. All the negative cells are connected together. Suppose each of this cell has 1.5 volt. When we connect together in parallel, the output voltage also will be only 1.5 volt. So is there any advantage in connecting parallel in terms of voltage?
No.
No advantage in connecting parallel in terms of voltage. Suppose we have 3 cells, each one having 2 volt EMF. Okay, if they are connected in parallel, how much voltage we will get?
Can you repeat the question?
If we have 3 cells connected in parallel, each of those cells has 2 volt. So how much will be the output voltage?
3. I mean 2, 2.
2 volt itself. So
Yeah.
what is the advantage is, even if one of the cell is faulty, it will work. But in the series, if one of them is faulty, it will not work. The current will break there, right? The circuit will break. But if they are connected in parallel, if suppose this battery doesn't work, then also the circuit will go on. Is that clear to you? The
Teacher,
resistance
if one is faulty, then the voltage will be same or less.
voltage will be same. No current
Why?
will flow through that. That's all.
Okay.
Current will come here. Instead of going here, it will go here. That's all. Okay?
Okay, teacher.
This,
Understood.
this branch will not work. That's all. So maybe when current come here, it usually divides into 3 branches, right? If this is not working, it's like a open. So it will not go here, it will go here and reach here. So there won't be any effect in the external circuit. Okay? So that is the only advantage. Otherwise, voltage wise, we don't have any advantage. Now let us see what will be the current if they are connected in parallel. So this is the formula. I will show on whiteboard how this formula is derived. You will be starting with the same equation. Okay, so let me just stop sharing screen and I will have to, I think, okay, with this and the highlight. Okay, so you can see the whiteboard now? Can you?
Yes. Yes, teacher.
Okay, do you remember the formula for resistance? Effective resistance when resistors are connected in parallel? Do you remember?
One by, yeah, divided 1 by 1 resistance plus 1 by another.
Okay. Suppose there are few resistors. I am taking like the previous. Oh, I'm again connecting them in series. Okay. Suppose there are more resistors. Suppose 3 resistors. I am giving just an example. Then I will work out for n resistors or m resistors. Okay. Suppose there are 3 resistors like this. Each R. Okay, so what will be the formula to find the effective resistance?
1 by R1 plus 1 by
1 by R plus 1 by R.
1 by Rp. Don't forget it is 1 by Rt, not Rp. 1 by Rp. Rp means effective resistance for parallel resistors. Will be 1 by R plus 1 by R plus 1 by R, right?
3
What
by
is
R
1 by R
plus
plus 1 by R plus 1 by R?
3 by R.
3 by R. Or what is Rp? 1 by Rp is 3 by R. So Rp will be equal
R by
to
3.
R
Okay,
by
R
3.
by 3.
R by 3. Okay. Now if cells are connected in parallel like this, each having the same EMF. Okay. Suppose cells are connected in parallel. So what is EP? What will be EP?
1 by E plus
E by
no.
E, teacher,
3.
E plus E plus E.
E, only E. I told you if we have E
Okay, yes,
cells
yes.
connected in parallel, the resultant EMF will be of only one, right? If they are all identical. You are learning now only the case of identical.
Yes, teacher.
So what will be
Yes.
this? It will be just E. Okay? So
Okay.
we will require these two cases when we are going to derive the current. So the current when the cells are connected in parallel. So for that, I will just show the cells, identical cells again. Okay, I'm showing only 2 here. Then I'm putting dots. Dot means there are M cells. Earlier we used the word letter N. That is why I'm using M. Doesn't matter whatever the letter is. And the external resistance is R. And all these M cells have the same EMF E. They have the same internal resistance R. Okay. Now, using this formula, can you tell me what will be Rp?
It's going to
M cells. There are 3 cells, RP is R by 3. So M cells RP will be R by M. For 3 cells, RP is R by 3, right? I just took this example so that you can explain, you can tell me this. RP will be R by M. And EP will be E. However, number of cells, it will be same. Okay? Now let us
Teacher,
use these values in the formula.
teacher,
Yes.
teacher, how RP is equal to R by M?
If there are 3 cells connected, you so R by 3. If instead of 3, there were M resistors, then 1 by RP will be
Okay,
1 by
okay, okay.
R plus 1 by R, etc. up to 1 by R M times. So you will get M by R, or RP will be equal to R by M. Okay? Is it clear? Yes, we
Yes.
extend, but instead of 3, there are M. So that we can come up with a general formula. So IP will be equal to EP divided by R plus RP. Now we are going to put these 2 values in this equation. So this is equal to EP will be E divided by R plus RP will be R by M. Okay. Now, in order to simplify this, I am multiplying and dividing both the numerator and denominator with M. Okay, I'm going to do this. I'm going to do this on this. Multiplying and dividing the both numerator and divided by M. Will it make any change? No, right? So, IP will be equal to ME divided by, when I multiply M here, I have to multiply on this term and this term. So M into R plus, when I multiply M here, 1 M gets cancelled. So by R. So this is the formula which we got finally. Is this clear to you? How we got this expression? I hope yes. So now let us take the first and second cases as we did before in the series combination. Let us take the first case. R is very much greater than small r. This will be the usual case. Then what can be neglected if R is very much greater than small r?
Small r.
Small r can be neglected compared to M times R, right? If R is 100 and there are 3 cells, this will be 300, this will be 0.1. So 300.1 is approximately 300. So we can neglect small r. So R can be neglected and therefore IP will be equal to, IP will be ME by MR, which is equal to E by R. ME by MR or IP will be equal to E by R. E by R means what? Current due to one single cell. E by R, which is nothing but current due to one cell. So is there any advantage in connecting the cells in? Oh, I'm sorry, I have drawn this figure wrong. It should be parallel, right? Why you didn't tell me? Should be parallel. I have drawn it wrong. Why didn't you tell me? Children, why you didn't tell me? I can make mistake. Please correct me whenever I do so. Okay? There are M cells. Okay? And there will be an external resistance. All are E. Okay. When I make such mistake, please correct me. You didn't notice that? Did you notice?
Teacher Irfan is waiting.
Yeah, I admitted him. Please correct me when I make such mistakes, okay? So this should
Okay.
be the resistance. This should be the, so is there any advantage connecting the cells in parallel if the external resistance is very much greater than R?
No.
No, because current due to one cell. Even if we connect many cells in parallel, the voltage we will get will be the voltage due to one cell only. Also, if you are connecting many cells in parallel, the current we get in the external circuit also will be the current due to one cell. So there is no advantage of connecting the cells in parallel if the external resistance is very much greater than small r. Okay, now the second case.
Teacher, can you say this one again, number 1?
Yeah,
Please.
see, when the external resistance is very much greater than R, R can be neglected. So this equation R will go and you will get IP is equal to ME by MR, or IP will be equal to E by R. E by R means what? Current due to one cell. Okay, not M
Yes,
times.
teacher.
So current due to one cell. So even if you are connecting 10 cells, you will be getting the current due to one cell alone. Suppose one cell can give you 2 ampere. You connect 10 such cells. Then also you will get only 2 ampere. If you connect 50 such cells,